Okay, so here are some of my work for the review problems from Chapter 8. Looking at number 1, I've got lengths in the rectangles of 20 and 32. And I want to find in simplest form the ratio of the length of the shorter side to the length of the longer side. So, 20 to 32. And I can then split that up into 5 times 4 over 8 times 4. 4's will cancel, and I get 5 to 8. So that's part A. Part B, ratio of the perimeter to the length of the longer side. Well, the perimeter is going to be 2 times 20 plus 32 all over the longer side, which is 32. So, sorry about that. So, let's see here. We want to pick. Alright, so we want to simplify that. And what I want to do is break down. That 2 in the 32 is immediately going to go, I'm looking at 20 plus 32 over 16, because the 2 over 32 is going to go to 1/16. Then I can look at, if I look here, I'm looking for common factors among 20, 16, and 32. So if I look at that then, greatest common factor among those would be 4. So I've got 4 times 5 plus 4 times 8 over 4 times 4, and I could cancel out a 4 in each one. So then I'm looking at 5 plus 8, which is 13, over 4. Done. Now, I agree. I could have looked at this a little bit differently and said, let me just go ahead and find that perimeter. I'll work with big numbers. And then I would have the 2 times 20 plus 32 would be, let's see, 20 to 52, that would be 104 over 32. And then I'm looking for breaking this down again, so I've got to take that 104 and break it down. I can see 32 is going to have a factor of 4. Does 4 go into 104? I think so. 4 times 26 over 4 times 8. The 4's will cancel. For the 26 and the 8, I've got a common factor of 2. So then I'm looking at 13 fourths. And I get the same answer. Okay, for number 2, I've got 2 similar quadrilaterals. So if I look at the order, U has got to correspond with C because it's the third letter in the similarities given. So therefore, angle U is going to be congruent to angle C. And for part B, I'm asked BC over HU equals AD over something. Well, BC to HU are the second and third letters in each of the 2 quadrilaterals vertices. A and D is the first and fourth in the first, so I've got to have T and S the first and fourth in the second. Okay, for number 3, we're looking at X to Y to Z equals 4 to 6 to 9, and I'm told Z is 45. Okay, so then I want to have X to Y to 45, and I've got to somehow match that up with 4 to 6 to 9. Well, 9 times 5 is 45, so if I were to look at this proportion, extended proportion here, or this ratio here, sorry, not a proportion, this ratio here, if I multiply everything by 5, I'm going to get a 45 here. So then I'm looking at 20 to 30 to 45. And note then that if I were to factor 5 out, what do I get? I get back to 4 to 6 to 9, which is what I wanted. So the question was x equals and y equals. Well, clearly then x equals 20 and y equals 30. Okay, for number 4, means extremes product theorem. I've got 8 times 15 equals 9 times x. And solving for x, I get 8 times 15 over 9 equals x. And then looking for a common factor, I've got a common factor in top and bottom of 3. So I'm looking at 8 times 5, taking the 3 out, over 3 equals x. I'm looking at x to be 40/3. Moving on to number 5 now. Okay, for number 5 here, let's see what we got. We're asked, or we're told, I'm given a over b equals c over 10, and I somehow want to know if that's true. A plus b over something equals something over 10. Well, the 10s we note match up in these two proportions in the denominators there, but the a has become an a plus b. How could I look at this first proportion and get that numerator there of a to be a plus b? Well, one way to do it would be just how I would add fractions. A over b plus b over b. Now, if I go ahead and add a b over b to one side of my proportion, I'd have to add the equivalent to the other side, which would be 1. b over b is 1. Now, my denominator over there is 10, so to write that one, I'm going to write it as 10 over 10 plus c over 10. Now look what we've got. A plus b over b equals c plus 10 over 10. And now, therefore, I'm able to go back and certainly answer what those two question marks are. Okay, here for number 6, note we've got a diagram over there with a couple angles marked at 60 degrees. If I look at that diagram, there are two triangles, and we should see that clearly each triangle has a 60-degree angle in it. And what else do you notice about the two triangles? Indeed, they share angle V, so I've got angle-angle similarity. Again, if I were to draw those two triangles out, I have here a V and A, which is my 60 degrees, and a B. If I draw the other one out, I've got, again, to match things up, I've got the V, I got N is the 60 degrees, and I've got the K. So then when I go ahead and list the order of similarity, I need to make sure I go A to V to B equals N to V to K, making sure I match up the corresponding vertices. And for number 7, from those similar triangles, all I got to do is match up corresponding sides. So A to B over N to K is going to equal V to A, and V to A is going to correspond to V to N. For number 8, angle VBA is congruent to which angle? Well, VBA is going to correspond to VKN, making sure I match up vertices in my similarity properly. Okay, for number 9, we're told we have a scale factor of 5 to 8, and that's AVB to NVK. Now I'm told VA is 2.5, VB is 1.7, and I want to find VN. Okay, well, VA to VN has got to equal 5 to 8, because that's going to be our scale factor, right? AV to NV's got to equal 5 to 8. So that then would mean that 2.5 to VN equals 5 to 8. If I then go ahead and solve for VN, by my means extremes product theorem, we then get 8 times 2.5 equals...
Like my podcast for the Common App.
Exactly. So 8 times 2.5 equals 5 Vn. Solve for Vn. We got Vn is 8 times 2.5 over 5. 8 times 2.5 is 20, and 20 over 5 is 4. Okay, for number 10 here, we're given a triangle over here with a segment parallel to one side, so we know, ding ding, we got side splitter coming into play, P, R, and S, P, T, and U. And for number 10, I'm told that PR is 10, and I'm told RS is 6, and PT is 15, and then I'm asked to find TU, which I'll call X. So side splitter tells me that 10 to 6 equals 15 to X. Now I can look at that 10 to 6 right away and simplify that ratio and see that it's going to be a 5 over 3 equals 15 over X. Then I could use my means extremes product theorem. 5 times X equals 3 times 15. Solve for X. X equals 3 times 15 over 5. 15 over 5 is 3, so X is 9. That's one way to do the problem. However, let's look at a couple of other things, a couple other ways that we might consider doing this. I'm going to put this back up here. So let's look at that again. When we got 5 to 3 equaled 15 to X, and I want to solve for X right away, I could reciprocate my proportions and get 3 to 5 equals X over 15, and then if I multiply both sides by 15, I get 15 times 3 over 5 equals X, and 15 over 5 is 3, and 3 times 3 is 9. So I could have gotten to the same answer. I also could have said when I set this problem up initially, I looked and I saw that I was wanting to solve for X. Now I went ahead just with my side splitter here and said 5 to 3 equals 15 to X, but I could have set up that side splitter differently right to begin with to get my X up top in a numerator and simply go on X to 15 equals 3 to 5, and then either using just multiply both sides by 15 and I've got X. So X is 15 times 3 over 5. X equals 3 times 3 is 9. Okay, so when you set up the side splitter, you might want to set it up, if you're looking to solve for a variable, get yourself the variable up in a numerator, and then all you got to do is multiply once. You don't need to use the means extremes product theorem if you've got the variable down in the denominator. Okay, for number 11, we got the same diagram set up. We've got a triangle. We've got P and R and S and T and U. And we got parallel, so we got side splitter. And then we know PT was 13. Sorry, PT was 32. And PU was 48. So if the whole thing is 48, then that's going to make TU 16. RS is 10. And I'm asked to find PR. And so this is pretty much the same as the last problem. I've got X to 10 equals, now at this point 32 to 16 is 2 to 1. Solve for X, X is 20. Okay, for number 12, same diagram once again. We've got a side splitter, P, R, S, T, U, parallel. I'm given PR is 14. I'm given RS is 7. I'm given RT. Now RT is right here, 26. Ooh, and we note side splitter never really involved these two segments here, did it? However, when we looked at our proof for side splitter, we looked at this diagram has two similar triangles. The little triangle is going to be similar to the large triangle. So, what are we trying to find here in this? We're trying to find SU. SU is down here as X. So if I go ahead and look at the similar triangles and set up my ratio of corresponding sides of the similar triangles, I would have side in small triangle to side in large triangle equals side in small triangle to side in large triangle. Go ahead and simplify your fraction 14/21 before you go any further. 2 to 3 equals 26 to x. Now at this point also, if your arithmetic is fairly reasonable, instead of using your means extremes product theorem and cross multiplying and if I look at this for a minute, I've got 2/3 equals 26 over something. I see that 26 is 2 times 13. So if I look at a 2 times 13 here, I've got to look at a 3 times 13 down here. So I can simply just visually look at this and go, look, I've got a 2 times 13, so I need a 3 times 13 in the bottom, so x is 39. Got it? Okay, for 13 and 14, our setup is we've got the angle bisector theorem. We've got a triangle, angles bisected, G, K, B, and E. And for number 13 here, I'm given GK is 5, I'm given KB is 8, I'm given GE is 7, and I'm given EB, that's what I want to find. So remember our pattern, at least that I recommend that you keep track of. You find your two sides of the angle that's been bisected, swing from one to the other, and that's going to form you your first ratio of 7 over x. And I could have also swung the other way, x over 7. As a matter of fact, if I want to solve for x, why don't we get x up there in the numerator? And so let's swing this way, x to 7. X to 7 equals 8 to 5. And then go ahead and multiply each side by 7. And there's no common factors between 5 and 7. So x is going to equal 56 fifths. And that fraction note is in simplest form. Now if you want to write it as a mixed number, 5 goes into 51. Let's see, 11 times, 5 times 11 is 55. And that leaves 1/5 left over. But again, you can go ahead and leave it just as a fraction, simplified fraction. Okay, so for number 14, we still have the same setup, same diagram. We're looking at angle bisector here, E, G, K, and B. And I'm given here GE is 14, and EB is 21. GB, now the whole thing here I'm told is 30. And I want to find GK. If I call GK X, and the whole thing is 30, that's going to make KB 30 minus X. So when I go ahead and set up my side splitter, and again I'm looking to go 14 to 21, X to 30 minus X, or 21 to 14 equals 30 minus X to X. In this case, either way will get the job done, because I'm going to have an X in both the numerator and the denominator. 14/21 equals X over 30 minus X. 2/3 equals X over 30 minus X. Go ahead, use your means extremes product theorem. You get 60 minus 2X equals 3X. That leads you to 5X equals 60, X equals 12. And the question was to find GK, and GK is X, so X is 12. Okay, for number 15, it would appear that we have our parallel lines cut by transversals, and we know that parallel lines cut transversals proportionally. And I'd like to prove D, F, get these labeled in, E, G, and J. And they've asked me to prove that DF times GJ equals FH times EG. Okay, so what do we know? We do know from our proportionality theorem that DF to FH equals EG to GJ. And that, my reason, if it's a two-column proof, would be if parallel lines are cut by transversals, then they divide the transversals proportionally. So go ahead and do your means extremes product theorem here, and you should notice you get DF times GJ equals FH times EG. And you're done. That was fairly easy. Finally, last one. Number 16. We are given a diagram, an A, B, X, D, C. I'm given BX is 6. I'm given AX is 8. I'm given CX is 9. And DX is 12. And I'm asked to prove line AB parallel to line CD. Well, we notice right away we have two triangles, and we've got vertical angles congruent. So the question would be, are these two triangles similar? Well, 6 to 12 does not equal 8 to 9. So clearly, if I'm not going to have triangle BXA similar to triangle DXC. Not going to work. But what about if I match up these two sides? How about 6 to 9? Does that equal 8 to 12? And it does. 6 over 9, does it equal 8 over 12? Indeed it does. 2/3 equals 2/3. And therefore, I've got SAS, triangle similarity postulate, for the two triangles because the vertical angles are congruent. So, I then can go ahead and I've got triangle, and I got to make sure I get my order right. BXA is similar to, now B is going to correspond with C, X with itself, and that leaves my D. So therefore, once I know that, ratios of corresponding angles in similar triangles are congruent, so I could get angle A congruent to angle D. And again, my reason would be corresponding angles in similar triangles are congruent. And what kind of angles are those? Those are alternate interiors, and therefore we know then that alternate interior angles give me parallel lines. So therefore I'm going to get AB is parallel to CD, and my reason is going to be alt interior angles congruent yields parallel lines. So those are review problems. Hope this helped a bit.